Okay, this is the six-step analysis process for doctor results. The idea of this structured approach is that any two engineers analysing the same set of results should come up with the same answer. And the six steps are these. The first one is the general view. In this we'll check for any anomalies in the readings, anything that might have gone wrong, and also get a general idea of what we're going to see. Secondly, we work from left to right on our graphs, and we look at the compression values for each of the cylinders. Thirdly, we check for pre-ignition. This is actually before the point where we measure compressions and can affect the compression values as well. Fourthly, we go to look at the ignition points themselves, where the diesel fuel is actually igniting in the cylinders. Spread of flame tells us about the condition of the injectors. And finally, we look at the power balance. This is an analysis of one of the engines in the samples database to demonstrate the six-step method. The first step is to make a general impression of the engine, which we do by showing the draw cards and the indicator cards on the screen at the same time, with all cylinders selected. From the indicator cards we can see clearly that the compression levels have some variation, and one cylinder is very low. And on the expansion side, which indicates how much power each cylinder has, we can see one cylinder with very low power. So we've got an idea what to expect when we analyse this engine. The next step is to zoom in, which I do with a click and drag box, and this zoom shows me the end of the compression phase, the ignition phase, spread of flame, and the start of the expansion phase. And this is where all the analysis is really undertaken. I'm going to select just the A bank and put a cursor on the traces, and I'm going to move the cursor to the left so that it's just before any ignition point. The cursor is now positioned just here. This is a good place to compare the compression levels before the ignition has taken place. On the A bank, I can see that I have 2 bars of variation. The ambient pressure is about 50 bar. So that's less than 5% variation. That's an acceptable level for an engine of this type. Moving to the B bank, I can now see that I have one cylinder which is extremely low, and I also have one cylinder which is high. The low one is the one to worry about. If this is caused by blow-by, you could be risking a crankcase explosion. More commonly, it would be a valve problem. That cylinder we can identify as B6. The next step is to look for pre-ignition, and I'm going back to displaying just the A bank. And in this, to find pre-ignition, if you examine the order in which the graphs appear at about -20 degrees before top dead center, and then look at them again where you evaluated the compression, which is just before the ignition point. In this case we can see one graph which is low at -20 degrees but improves in pressure before the ignition points, and that can only happen by fuel burning in the cylinder, which can come from a leaking injector needle. So we need to identify that cylinder and find out which one it is. That turns out to be cylinder A6 with pre-ignition. On the B bank, we do the same test. We're looking for a cylinder at -20 which has risen up compared to other cylinders by the time we come to the cursor position. In this case, the cylinder that is very, very low in compression, in fact, is starting to catch other cylinders up in this area. that indicates strongly that there is pre-ignition on that cylinder. The next step is to look at the ignition points. The program is able to do that for us, and the best place to see these is if we select the bar graphs. In the bar graphs, the parameters, the various parameters for the tests are indicated, and at the bottom here we can see the ignition angles. The spread is from -1 degree to +2 degrees, so we have a 3-degree overall spread in the ignition points. The A bank is predominantly below the line, which is -1 and 0. The B bank is predominantly above the line, +1, +2 degrees. So we have a bit of variation, and it's systematic across the engine, with the A bank firing ahead of the B bank. After the ignition points, we're looking at the spread of flame in the cylinders. The gradient of this rise of pressure indicates how the flame is spreading in the cylinder. And if we get a low gradient in this area, that would indicate poor spread of flame. It might be due to poor atomization or even hosing of the fuel into the cylinder. In this case, the graphs are fairly uniform. There are one or two here that might have slight lower gradients, but there's nothing there that would be considered to be untoward. Finally, we go to look at the balance of power in the cylinders. From this area of the graph here, we can tell that this green line is going to show much lower power, and we can identify this curve. It's B2. Again, going to the bar graph of results, we'll see that that cylinder B2 in the power line is very low. To see the actual values, we can go to the table of results, and the total power is indicated here, 1532 kilowatts, and the variation between the cylinders is 39.1%, largely due to B2, of course. If we take away B2, we find that the overall variation is now down to 19.2%. With the A bank, by selecting here, the A bank is now responsible for only 8.6% of the variation, the B bank 12.8%, and overall we have 19.2%. So we know there's variation in the engine, we know that the banks are imbalanced, and we know that cylinder B2 requires a lot of adjustment. So we can create a report automatically now in the Doctor program. Highlight the result and click on the report button. Make sure that the diagnostic statements and status indicators are going to be shown, and then print. And our report shows exactly the answers that we got from the manual analysis. Validity test, 2 cylinders don't have results. Compression comparison on the A bank, it's good compression, but we have slight symptoms of ring or liner problems on A3. We didn't actually pick that up in the analysis, but this tool is perhaps a little more comprehensive than I was demonstrating manually. The B bank, however, we find that the lowest cylinder is B6, which we certainly did pick up, and B2 also slight symptoms of ring or liner problems. Overall, we have a 14.2% compression variation and a systematic variation between the A bank and the B bank. Pre-ignition. Cylinder A6 we found manually to have pre-ignition, but on the B bank, B6, which was the cylinder with very low compression, we also found pre-ignition. In this case, we give a warning in that the compression at -20 degrees is very low, and if that is due to blow-by on this cylinder, you are risking a crankcase explosion. Commonly it would be a valve problem, but the warning is given anyway. Moving on to the ignition points, They were pretty good. A bank and B bank both get green indicators, and the variation 2 degrees on the A bank, 1 degree on the B bank. But overall we have 3 degrees of variation, indicating that there's some systematic timing difference between the A bank and the B bank. The spread of flame, we didn't find any particular problems with the cylinders there. And finally, on the power balance, we found that the A bank had 8.6%, the B bank 34.1%, and overall 39.1% variation. All mainly due to the cylinder B2, which has very, very low power. B2 didn't have any other problems mentioned, so it just requires its fuel amount to be increased. The other problems, of course, require a bit more work to address. And that completes the 6-step analysis, both in manual form and in the automated form using the reporter. And the same techniques can be used on any engine, 2 strokes, 4 strokes, any engine that you might have in your fleet.